What's good? It's your boy Jay with the J Academy. Welcome to another episode. And today we're going to be talking about the kidneys and how they function. So let's get started. So here we got a kid and here we got a knee. And together they make a kidney, which is located right here in the body, as you can see. So what are the functions of the kidney? Well, there are 7 functions and you can remember them with the mnemonic, a wet bed. Right, so the first function of the kidney is acid-base balance. So the kidney can actually control how much of the hydrogen ion, which is acidic, and how much of the bicarbonate ion, which is basic, and how much of those are in the blood. Second is that it can control water balance. Third is that it can control the electrolyte balance by controlling the amounts of sodium, potassium, and other electrolytes in the blood. Now, fourth is toxin removal. So it can remove toxins, say if you're taking drugs, or stuff like nitrogenous wastes from the body, especially urea. Fifth is blood pressure control. So if it can control the level of water, then it can also control the level of fluids in the blood vessels, which affect the blood pressure. Sixth is that it can produce erythropoietin, which is a hormone that tells the bone marrow to make more red blood cells. And lastly, it controls vitamin D metabolism. So how does it do most of these things? Well, to really find out, we have to go and learn about the functional unit of the kidney, which is called the nephron. So let's go over the anatomy of the nephron. So the nephron is supplied by a blood supply called the glomerulus, right? So the glomerulus is a tuft of arteriole and it's at high blood pressure and actually forces the blood out and into the nephron through the Bowman's capsule. So the Bowman's capsule is the first part of the nephron. And the glomerulus and the Bowman's capsule, those two combined are called the corpuscle. Now the next part of the nephron is the proximal convoluted tubule, and then the loop of Henle, and then the distal convoluted tubule, and then the collecting duct. And the collecting duct is where the waste products are excreted into the bladder, where they make urine. Now, all of this is surrounded by a blood vessel, or many blood vessels, and that's called the vasa recta. And what those blood vessels do are they reabsorb the stuff that goes into the nephron. So, as we can see, the nephron has a few functions, and the first is reabsorption. So reabsorption is when stuff from the nephron goes back into the vessel where it goes back to the body. Secretion is when it goes from the blood vessel to the nephron. So it's being secreted into the nephron. And excretion is when the nephron gets rid of things through the collecting duct, where it goes down into the bladder and it gets urinated out. So that's called excretion. X is exit, to get out. So it gets out of the body. Right, so now let's get into the function of the nephron. Right, so first is filtration, right? So then this glomerulus is at a high blood pressure. It forces the blood into the Bowman's capsule, and now it's called filtrate. So what can get through is water, sodium, glucose, and potassium, all the little stuff. Now the big stuff like red blood cells or proteins, they can't get through unless there's something going on right here and it's damaged. Right, so next is the proximal convoluted tubule, and it's responsible for most of the reabsorption. So how you can think of it is that the proximal convoluted tubule does most of the reabsorption, and the distal convoluted tubule fine-tunes the reabsorption. Right, so the PCT reabsorbs 65% of the sodium, water, and also potassium, pretty much all of the glucose, and 90% of the bicarb. So remember, the bicarb is a base. So you don't want to absorb too little, because if you reabsorb too little of the base, then your blood gets acidic, right? So in that way, it controls your blood acidity. And right over here at the PCT, it also secretes uric acid. So uric acid goes into the nephron at the PCT. And uric acid is a waste product. Right, so next is the loop of Henle, right? So what the loop of Henle really does is it wants to reabsorb the water and also reabsorb more of the sodium. So how it works, we gotta look, it goes this way, right? But let's actually go backwards because it'll make more sense. So this is the ascending limb because it goes up, and then this is the descending limb because it goes down. Now the ascending limb is impermeable to water, right? So that means water can't get in. But the sodium is actively transported out into the interstitial space right over here in between the two limbs. And since the sodium gets actively pumped out, that draws the water from the descending limb into the interstitial space, right? So the sodium attracts the water. The sodium is first pumped out, it attracts the water, right? And now, so the water comes out, so it's mostly just electrolytes and whatnot over here, right? So it's really concentrated, right? And then then most of the sodium right over here is absorbed, and so is the water. And now the next part is the distal convoluted tubule, and over here it kind of just fine-tunes things, so it reabsorbs 5%, really little of the sodium and also a little bit of the potassium. And over here the hydrogen ions are secreted, so hydrogen ions, which are acidic, go into the distal convoluted tubule. So if there's too little hydrogen ion secretion, then your blood can also get acidic right over here, right? And lastly is the collecting duct. So, all the waste products they have collected at this point, and they're gonna go out, right? So some things that are gonna go out are water, sodium, potassium, and urea, which is a nitrogenous waste. And so those are all gonna go out, and they're gonna go out into the bladder as urine, and that's gonna go out of the body. All right. So that's it for the overview of the kidneys and the nephrons. I hope you learn a little bit or a lot. And as always, it's your boy Jay signing out.